Hello everyone. I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Today we are discuss about the topic is bus system for register and 4-bit arithmetical circuit. So now the first of all we are discuss about 4 register for the bus system. So the next is So now the first of all, we can show that what is the register. Register is used for the data store and data hold for any device. So each register have a 4-bit number for 0 to 3. The bus is a consistent of 4 cross 1 multiplexer is used, each having a 4 data input up to 0 to 3 and 2 selective input for S1 and S2. We can show that. This is the diagrams. Here we can show the diagrams. Here 4 multiplexer we can use. And each and every multiplexer have a 2 inputs is a selective S1 and S0 and 1 register we can input. The 2 selective lines S1 and S0 are connected to the selective input of the multiplexer. The selection line choose of the 4-bit of the 1 register and transfer the theme into the 4-line common bus system. Here we can show that the 4 register is used is directly connected for the multiplexer for each and every terms. Here the remaining will be connected. Here C2 will be connected here. So each and every multiplexer is connected. Here we connected A0, B0, C0 and D0, A1, B1. The sequence we can follow. And 2 selective input will be S1 and S0. So output is 4 common bus system. So the next is when S1 and S2 equal to 0, 0, then the 0 data input for the all 4 multiplexer and applied to the output is multiplexer is 0. It means if S1 and S2 is 0, 0, then all the common bus system will be output will be 0. So when the register B, if the S1 and S2 is 0, 1, that given some the output as per the register is selected S1 and S2. If you select, for example, register 1, then S1, S2 will be 0, 0. Then after B will be select S1, S0 will be 0, 1. Then after 1, 0 and 1, 1. So based on the selective register, you get one output. So this is the common bus system for the 4 register. So the next topic is 4-bit arithmetical circuit. We can show that the 4-bit arithmetical circuit. As shown in diagrams, 4-bit arithmetical circuit as shown in figure. This is the 4-bit arithmetical circuit. We can show that here full header we can use, multiplexer we can use, C of I and 2 selective input we can use S1 and S0. What is the full header? Full header is provide the 3 inputs and 2 outputs. It means this is the 3 inputs X0, Y0 and C0 and 2 outputs is C1 and D0. So what is the concept of full header? The concept is here we can forward the next full header and this is one output. So all the full header is connected based on the concept. Here we can forward it and 1 is a output. So here D0 is a output, D1 is a output and C1 we can carry and carry can forward the next full header. This is the basic concept of full header. You know that the multiplexer is a 4 input and 1 output. So we can show the some short description of the 4-bit arithmetical circuit. The description is given here. We can show the diagrams of the 4-bit arithmetical circuit. We can show that it has 4 full header circuit is used for the full header, and 4 multiplexer choose the different operation. It means each full header we can choose the different types of operation. So the next is where A is a 4-bit binary number and X is a input, and Y is a 4-bit binary number and Y is a input for the binary header. We can show that here one use of X and Y. What is the X and Y? X and Y is a input number of A0 and Y is a input number of multiplexer output, and C will be either 0 or 1. C of n is the input of carry is 0 or 1. So what is C? C is a carry for either 0 or 1. Here the two selective input S0 and S1. Here we can show that two selective input S1 and S0, and we can connect it to multiplexer. So we can use the selective input of S0 and S1. Now the next is A0 value is 0 or 1. B0 value is 0 or 1. In B0 is connected in inverse gate. It is generate the 8 arithmetical micro operation. We can show the diagrams. Here the two inputs always we can show that some sort of description here. If carry C of n will be 0 or 1. Okay. The next is S1 and S0. We can always 0 and 1. Then after, what is the A0? Suppose A0 is 0, then B0 is 1, then this is the inverse gate. So here is always 1. If B0 is 1, then inverse will be 0. This is used for the inverse gate. So now finally the multiplexer given one output, and output is connected for the full header input of Y0. A0 is directly connected of X0. So finally the given the input is X0, Y0 and C0, and give the output is C1 and D0. D0 is the output, C1 is a carry. The carry we can forward the next full header. So this is the 4-bit arithmetical circuit. So the next is arithmetical circuit function of table. How can you perform this operation in particular function table? We can show that if S1, S0 and C of n, then will be 0, 0, carry will be 0, then Y input will be B, then our output is performed D equal to A plus Y plus C of n, and micro operation will be add. So this is the selective input. If you select this type of input, then Y will be here, then output D will be performed A plus Y plus C of n. Then micro operation is performed, some addition, add with some carry. All the here operation is performed. What is the D? D is here, D0, D1, D2, D3. So this is the D operation. Then finally Y operation is here. So we can show the 4-bit arithmetical circuit. This is the some diagrams. So thank you all of you.